All right, so I'm going to try this one more time. My iPad has not been recording today, so I'm having mechanical issues. So here we go. Today you are doing, this is part of section 12.4. You're doing page 554, number 1 through 9 all. Today what we talked about were parent functions. I'm going to slow this down a bit. Okay, I'm going to pause it. Okay, so what I mean by a parent function is that this is the most basic form of an equation without any modifications to it. So when I'm talking about lines, we're using x to the first power. So if I'm doing, something like this, I'm doing y equals x, I make myself a table, and then I can do the y equals mx plus b, where my m is 1 and my b is 0. I can start at 0, or I can use the points from my table and draw the line. Now this is what we call the parent function, because there have been no modifications to the x or the equation. All right? So if I want to make a modification, if I get something like y equals negative x, now that, remember that negative has 3 different definitions. It means minus, it means negative, it means opposite. So now what I'm doing is y equals the opposite of x. So I can make a table, or I can put it into slope-intercept form and find my m is -1 and my b is 1, 0. I can start and plot the points and then draw the line. And then what you see is now we've got y equals x is the parent function, and then the new equation is just a modification, a transformation of that original equation. And that is y equals the opposite of x. And so the opposite flips the line around to a negative slope. Okay? So we started with lines. Okay? Parent function. X is to the first power, it's going to make a line. When I do the opposite of y equals the opposite of x, y equals negative x, we get the opposite direction. Okay, because that negative means opposite or negative or minus. All right. Now let's go to an absolute value equation. Let's look at the parent function for absolute value. Okay, so this is basically, if I write the f of x, that's like saying y. So I can make myself a little table. And when I take the absolute value of x, remember we're choosing our x's. Okay, so if I choose -3, I'm doing the absolute value of -3 is 3. -2, the absolute value of -2 is 2. -1, the absolute value is 1. Okay, 0 is still going to be 0. +1, the absolute value will be 1. And then we can plot those points. Okay. I'm going to plot, and what you see is a shape, and it is a V. Okay, so what we have here when we have absolute value is a V, and the parent function, notice it's coming right out at the origin. The slope is 1, going in both directions, in the positive direction and the negative direction. If we make a transformation to that parent function for the f of x equals the absolute value of x, okay? So we could do something like, I'm just drawing over it in black. So let's go through first and talk about our domain and range. So with our domain, notice it's going to get wider and wider and wider because it goes on and on forever. My domain is any real number because it keeps getting wider. But my range, what is the highest it goes? It has a minimum. Okay, the minimum it hits on the y-axis is 0. So we're going to say y is such that y is greater than or equal to 0. Okay? All right, so let's try another let's try transformation now to that parent function of absolute value by subtracting 2 in that equation, okay? Making myself a little three-way table. And now, doing the absolute value of negative 2 minus 2. So it's 2 minus 2 is 0. Absolute value of negative 1 minus 2 is negative 1. 0 minus 2 is negative 2. Let's try positive 1. So 1 minus 2 is negative 1. And then we go to 2. And we'll notice that this 2 makes a V. And as I plot it, what has happened to my V in relation to the parent function, the black line. Notice the equation. Notice the graph. What kinds of changes have happened? What happened to this V? We know it makes a V because of the absolute value. But now notice, it dropped down 2 units because it says minus 2. So that minus 2 on the other end of that parent function, on the new function, has dropped the vertex down 2 units. It's shifted it vertically down 2 units. All right, let's try another kind. Now, if it had said plus 2, the vertex would go up 2 units from the origin. Now, let's try another kind of transformation, and that would be multiplying absolute value. So if I do the f of x equals 2 times the absolute value, okay, I can make my table. I'm saying, negative 2, when I take times the absolute value, I'm 4. I'm doing this pretty quickly. And then I'm going to plot the points. Okay? As I plot them, what I want you to notice is what happened to it. Okay? It's still at the origin. The only difference is it's skinnier. It's skinnier. Okay? So notice when I'm multiplying by a number greater than 1, the V gets skinnier. What do you think would make it wider? That's right, you guessed exactly right. A fraction will make it wider. So, multiplying by a whole number greater than 1, remember, if you're multiplying by 1, it's the parent function. If it's greater than 1, it's going to be wider. It's going to be narrower. And if it's less than 1, a fraction, it will be wider. Okay, so a whole number greater than 1 will be skinnier. A fraction or a decimal will be. Now, what would happen to the V if we went and multiplied it by a negative? Yet one more transformation. Okay, what that does is it takes the opposite. It flips the original parent function and it flips it upside down. Now, each time you do this, we have to also think about, your domain and range. I didn't do it for the other two, but you're doing that tonight. Okay. Let's see, I think that's the end of it. Let's see. All right. Let's go to, I'm going to pause it. All right, so now let's take those transformations and apply them to a quadratic equation. Today, we're just starting with the f of x equals ax squared, maybe plus x, but we're not doing full trinomials. Okay, so let's start with our parent function, the f of x equals x squared, or y equals x squared. I'm going to make myself a table, and when I square negative 3, I get positive 9. Okay, I'm going to plot that point. I'm going left 3, up 9. When I square negative 2, I get positive 4. I'm going left 2, up 4. When I square negative 1, and when I square 0, I get 0. When I square 1, I get 1. Now, here's where you get a couple of free points and you really don't have to do any more math. Okay, and that is because a parabola has a symmetrical side. So you can notice if this is the midpoint, the midline, the line that breaks it up, the parabola up, notice I can add, this point is 2 units to the left, I can go 2 units to the right. This is 3, Go 3 units from the middle. That middle point, that middle line has a special name. That is called the axis of symmetry. So you can kind of get those extra points instead of doing the math here. So we call this bottommost point a vertex. It's 0, 0. And we call this line that splits the parabola in half into symmetrical parts, we call it an axis of symmetry. And we identify it by where does it cross the x-axis? At what point? So if this is, let me go here. If this is a number line, and that's 0, that's 1, that's 2, that's 3, it's crossing -1, -2. It's crossing at 0, okay? So it's crossing at 0, so we say the x-axis of symmetry is equal to 0. And it's also the x in your vertex. That's your x in your vertex, okay? So now let's do a transformation to a quadratic, an x squared. Quadratic is x squared. Now this time, what do you think is going to happen to that parabola if it says x squared minus 5? Hopefully you're guessing right. And that parabola is going to drop down 5 units. It's going to shift vertically down 5 units. Okay, so I'm going to take -3 squared is 9, minus 5 is 4. Plotting the point. -2 squared is 4, minus 5 is -1. I'm going to keep doing this. Now I got my free points. I'm going to draw it. My vertex this time is 0 across, -5. And then my axis of symmetry is x. Now, the other thing you have to do tonight is you are going to have to identify your domain and range. And in this case, this domain, notice it's going on and on and on. We're going to eventually, so this is, let's look at this. This is 1, 2. This is a 1, 2, 3. I'm not talking about the y's because the domain is just the axis. And since it's at a slant, this is -2. This is negative. And you can see right here, if I continue the pattern this way and this way, my domain is going to be x is any real number. And you can use that fancy R. Okay, whereas the range has a boundary. Okay, where does the range is the y. The range is the y. So I'm going to do my range. Y is such that y, the lowest possible point on my y-axis would be -5. So y is bigger than or equal to, greater than or equal to, -5. Okay? So that's your domain and range. I don't know if I did that before. Okay, my domain and range here, my domain, x is any real number, and here my range, y is such that y is greater than or equal to, it actually touches the 0, greater than or equal to 0, okay? All right, let's try another. Okay, this time, what's happening to my parabola? When I see +4, it's going to shift the vertex up 4. When I see the negative times the x squared, it's going to flip the parabola upside down. So it should be an upside down with the vertex. It's a great way to check yourself. Now, this is an imperative part of this. I had a number of students that are trying to do this, and that's wrong. If you did that first, you're multiplying before exponents. Okay? You have to do -3 has to be squared first, and that becomes +9 times -1, and that makes -9. If you just do negative times negative, you get a +9 plus 4. It's going to be a wrong answer, and it's going to affect you the rest of the time. So, you got to do your exponents first, do your order of operations, your PEMDAS, okay? So on the next one, remember, if I'm doing I'm doing negative 2 squared is 4, so that becomes a negative 4 plus 4, that makes 0, okay? Then I'm going to keep doing that. Let's look at what happened. Notice the vertex is 4 units up, and it's flipped upside down because of that negative, okay? All this is building up to eventually utilizing those ideas for graphing. My new vertex is 0, negative 4. My axis of symmetry is still 0. It's crossing through the x-axis. And then I'm my domain and range. This time, my domain, it's going to keep getting wider and use all the different x's. So my domain is x is any real number. Okay? My range, y, is such that y, this time, where does the maximum point on the y-axis? That's 1, 2, 3, 4. Y is less than or equal to 4. Okay? All right, let's try another. Let's look at another. Okay, let's try this one. I'm going to just substitute in the numbers really quick and get some points on the graph. And I want to talk about one last thing. Okay, now tell me what the axis of symmetry is. What is the vertex? Let's start with that. Vertex. Vertex is 1 across, 2 down. So 1, positive 1, negative 2 is my vertex. Okay? And then we've got our axis of symmetry, which is what goes through the vertex. Where does it cross the x-axis? It crosses at 1. So my axis of symmetry is equal to 1. Okay? My axis of symmetry is equal to 1. And then we've got to do our domain and range. My domain is any real number. X is any real number. And my range would be, my range is going to be y is such that y is greater than negative 2. Greater than or equal to, you have to say negative 2. Okay, and my domain is x is any real number. Right? All right. I've got one more I want to show you. All right, what happens if we have the decimal? Again, remember, decimals and fractions are going to make it really wide. And then we've got our negative, which is going to flip it upside down. So when you get a point like this, you might not be able to graph it exactly. It's within your frame, but notice I'm going to go over 1, 2, 3, and then down 1, 2, 3, 4, 5. I'm going just under it because it's 5 1/4. Let's go here. Okay, do you see how I'm kind of just under it? That's a little bit too much. Let's go right there. Okay, if you look at it, so you're going to have to estimate it. You're going to have to estimate it. I think I did that one. Let's see. Okay, so we went 1, 2, 3, down 5. Okay, I'm going to plot those. Let's look at those. Okay, oh, darn it, that's what I wanted to see if you knew. Okay, so I'm finishing the graph, and you can figure out what the rest, but now we can figure out what is our vertex, because it's starting to go down. My vertex is, I can do these extra points. This one's over here, and this is, okay, so notice I'm 1, 2, 3, so I'm going to go 1, 2, 3, and just right on it right here. And then I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, right on it. And then I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and I'm just under the 5 line there. so there we go. That's our parabola. You have to connect the dots. You have to. If you're not connecting points at this point, it's a problem. Okay, and so my vertex is 2, 1, and my axis of symmetry, my AOS, goes through positive 2. Notice it's the same thing as the x. All right. And that, my friends, is our lesson.